Hi, it's me Jazzy. I'm back with another tech related video, and today it's part 2 of the BD electronic signal tracer kit. So we built the main unit in the last part of the video and tested it, and it works and it looks fabulous. So today we're going to build the probe. Now this is the tube they've sent us that we're going to build the probe in, and all the components are inside. Fantastic. So we're going to build this, solder the cable on, which is going to plug into our unit here, and then we can try it out in some fault finding scenarios. This is going to be great for working on amplifiers and old radios, and I've got a lot of old radios to work on. So let's get over to the bench and start building this probe. Right, so here we go for part 2 then. So we've got our little base unit that we built last time, so that's ready to go. Got the battery connection that we soldered up. This is going to be for the probe, and this is all the bits that we're going to need to build the probe. Fantastic. Got my instructions here that I've printed out so I can follow along with those. So let's have a look what we've got in here. There should be everything we need. There's our little PCB. Oh, very nice. Okay, we've got all our components here, so we're going to need this. This is what we're going to build the probe in when we're ready to. So we've got another piece of wire here, and here's our components to make our probe. So again, as usual, let's sort them into what we've got. Resistors there. There's a little clip. Croc clip, and this I believe is going to be the actual probe. Right, I'm intrigued by this, so we're going to need our little PCB holder. Let's bring this one in. Now I thoroughly enjoyed building the main unit in the last part of the video, so I am very much looking forward to getting to grips with this probe. So we are starting as usual with resistors, and we are starting with location PR1. Now, where is PR1? PR1 is here. Now, this is a 100k half watt resistor, which is brown, black, yellow, gold. And we've got our little component tester here, so we can just check it is what it should be. 98.9798 k ohms. Okay, that's fine. These are 5% resistors, so that is within spec. That goes in here. Nice, that's our first one in. Now we've got two the same here, which are, and these are both the same, these are 68k ohms, which is blue, grey, orange, gold. Double check on these. 68k, just in case. Yeah, 67.24, absolutely fine. So this is PR2, this goes in here, and this one's going to be PR3. Okay, just 3 resistors on this one, nice and easy then. Okay, let's get these soldered in. There we go, fantastic. That's our resistors in. Very much looking forward to testing this signal tracer kit. It's going to come in very handy. I need to get started on some of my old radios. I've got way too many that don't work. So diode location is next, which is PD1, which is... Right, now we're looking for a 1N34A, which is described as a clear body with red-orange stripe, or 2 stripes on one end. Well, that's clearly going to be these. Now it says refer to the image to locate the cathode end, and it does indeed give you on here the cathode end is here. Just got to go this way. Again, if you're unsure, you can use the good old component tester. See, the cathode end is there, look. So you can see the correct orientation is this way, because that is where the cathode end is. So if you're not sure if that's the cathode end, you can use the component tester, and that confirms for you that indeed it is. So that is the orientation we want. And you can see that's denoted by the little line there, the little line denoting the cathode end of the diode. So you can see with PD2, the little line is this end. So you want to have your cathode end there. You can see your cathode, the little orange part. And again, confirmation is always a good thing. You can see which way around the diode symbol is, meaning we have got that the correct way round. It goes in there. Okay, that's rather fabulous. So if you've not worked with germanium diodes before, it's quite easy to get caught out by them. These are what are generally termed as Russian germanium diodes. Doesn't necessarily mean they're from Russia, it's just a general term for them. But the markings can be sometimes at the opposite end to what you would expect. So you can see here with this regular diode, generally you'd have a band there denoting the cathode end, which is the band that you would line up with the band on your PCB. Now with these so-called Russian germanium diodes, the band is sometimes at the other end or even in the middle. It's not consistent. And this is a really good scenario where something like your LCR tweezers comes in really handy, because it gives you that visual confirmation there as to which way round your diode should go. It shows you quite clearly there which is the cathode end, and we can see we've got that one incorrectly there, and with this one the cathode end should be facing the top, which it is. So we know we're all good, we can go ahead and solder those in. Now of course, if you're very experienced with electronics kits and components, you would probably know that, but if you're just getting started, it's really easy to get caught out by that. So today's top tip there for Russian germanium diodes. Oh, this is already building up quite nicely, isn't it? So now we've got a capacitor to go in, and that's going to go in PC1, which is here. Now PC1 is a 150 nanofarad polyester film, orange drop style, and it says in the instructions it's marked 154, and it clearly is marked 154. This is a 150 nanofarad. Again, we can confirm that with our LCR tweezers here to make sure. Yeah, 151.2 nanofarads. There we go. Now, what they've done in the diagram, which is rather handy, they've given you this diagram here. You can see they've got it laying down, and that's because it's got to fit inside our tube that's going to make our probe. So what we're going to do is we're going to put it in there and there. These two holes are linked because it may vary which components they send you, and then we're going to give it just enough so we can lay it flat. That's it, against the board there. That's it, perfect. So we've got enough clearance then to fit it inside the tube. Right, let's get that one soldered in. All right, let's clip these off. Fantastic. Got the shakes today, I don't know why. Sometimes I do. Anyway, that one's in. Now I'm looking for a 100 picofarad ceramic disc, which I believe is this little one here. It does tell you in the instructions it's marked as 101, so if you're not sure, it does say 101, and we can check it with our LCR tweezers just to make sure it's 100 picofarads, and it is 104.4 picofarads. There we go. And that goes in PC2. PC2 is here. Okay, and then we've got PC3, which is a 1 nanofarad, which has got to be this because it's the only one left. So I'm pretty sure this should test as 1 nanofarad. Yeah, it does. Exactly 1 nanofarad. Wow, okay, that's a good one. That's a good one. We like that. And that's going to go in here. PC3. I get carried away with these things. It's a certain joy when something tests very accurately like that. We get these in. Won't take as long to get this probe together. Really must get myself a more effective fume extractor. Now, our probe. Locate and install the T-pin probe tip. So this is the point where we're going to need to move the board and have it oriented a bit differently in here because we need to be working on this end. So I'm now going to move these in. That's why I love this PCB holder, because I can have it like this and it's not going to smush any of the components that I've already put on the board, which is rather nice. We don't like smushing. There's no need for that. This is probably a good time to bring in the scrap mag there. There you go. A handy little gadget that is. Do love a handy gadget. Right, now we're going to install this T-pin probe tip, which is this here. So what we're going to do is we're going to use one of the discarded component legs. We're just going to bend it there so it's a bit like a staple kind of thing. So we've got 2 holes there, and we're going to use those to insert this. That's it. So this is going to hold the probe in place. Well, at least once we've soldered it on, it will. So what we're going to do is we're going to just solder that first. We're going to flip it over, and then we're going to attach this to the pad that it's on, so it's not going to move. Let's solder this in first then. So we want to try and get this to sit. Now this is a great scenario for burnt fingers. That's what somebody commented on my last video, that if you never burn yourself, you're not doing it right. So all I'm doing now is I'm just making sure there's enough solder in there so that the probe is going to stay on this pad and it's not going to move. And I'm doing a really overkill job. Lovely. Put a little blob on the back. There we go. That is not going anywhere. But I think that looks all right. I think that looks fairly straight, even with my wonky eyesight. I think that's all right. So I think we're nearly there. I do believe we need to solder some wires onto here. So the next thing we're going to need to do is we're going to need to make a hole in the tube for the probe. Now it says you can use the moulding mark there as a guide where to drill. So I'll get my little Dremel thing out in a minute and we'll drill a hole in that. There we go. So hopefully this should fit inside. There we go. That's not bad, is it? Okay, so that one's all right. So now on this end, we need 2 holes. The middle hole is going to be for this screened cable, which will go to the probe. And then we're going to have a thinner hole for this ground. So you don't want the holes too close together because you don't want the cables running too close to each other because you don't want any risk of interference. So we need our larger hole in the middle and we need a smaller hole about halfway out, it says. So I'm going to go about there. Without drilling through my mat, which I nearly did. Enough to get our ground wire through, and it is. Lovely. Now we need a 3mm hole. We've got a 3mm bit here. I'm going to use this small one though to make a little pilot hole. Would be easier if I put the top on the thing, wouldn't it really? Then I'm not going to drill through my mat. Right, so there's our pilot hole. Now we can change drill bits, which is a complex scenario on this thing because it means I have to change this chuck. It's a bit of an odd beast, this thing. So now we can enlarge, if that's a word, our hole to 3mm. That should do the trick nicely. So that should hopefully be enough to get this through. Yep, perfect. Okay. That's done then. Okay, so now we've got our holes for our probe tube. We can feed our wire in. So one thing to be aware of with this is you want to have the plug on this end, i.e. outside the tube. Otherwise, you're going to have all sorts of problems trying to plug it in. So I'm just going to thread that through. And this is going to be the ground wire. This is what the little croc clip is for. That's going to get soldered onto this in a minute, and that's going to be your ground. So that's got to go through as well into there. Fantastic. There we go. Right, we're getting somewhere now. So now we need to prepare the end of the cable. So this is almost like a coax type of cable really, in that you've got a shielded cable around the outside. We need to remove some of the insulation from this. So let's strip a little bit off this one. Lovely. So you can see there is your shielding wire. We're going to twist that together. Okay, now we need to strip a bit off of here. Great. Okay, so we've got our center wire and our shielding wire. So what we want to end up with is something that's looking a bit like this. So the ground wire comes in and is wrapped around the shielding wire, and that's going to get soldered to that. So let's do that now. So we're going to need to strip a bit of insulation off the ground wire, just enough. There we go, nice and easy, and that is going to get wrapped around the shielding wire here. And then we need to solder these together, but we need to keep this end going because we're going to be soldering this onto our PCB in a moment. Let me just grab something to hold that while I'm soldering it. This is where the Omnifixo comes in handy yet again. We are going to have to now solder that onto our PCB, which is here. So we might as well use this as we've got it out now. Right, so you can see that it's marked quite clearly here, output and ground. So we want to put the one that we've just soldered together, that needs to go through the ground. Just cut off the excess. Lovely. Now we just got one more. Now what we want to do is very carefully put our signal wire through the hole marked output. There you go. Just a quick solder on that and we should be good. Perfect. Let's cut off the excess. Lovely, not the neatest solder joints in the world, but it'll do the job. Now we've got this here, we've got our ground to the ground and our output to the output, and we're looking good. Now's the time we find out if I've got this soldered on straight. So it should go through the hole at the bottom of the tube, like such. And then this, if we've done this right, we'll pull through and we can screw the top on. There we go. And this is going to be our signal tracing probe. Look at that. That's not too bad, is it? That's not perfectly straight, but it's not bad. Anyway, that is done. So we literally have one more thing to do, which is to prepare the end of this to have the crocodile clip. There we go. We've got our crocodile clip, or alligator clip if you prefer, depending on what you want to call it. I believe it depends on if the clip will see you later or in a while. That generally denotes if it's an alligator or a crocodile, does it not? Is that just me? That might be just me. So we have got a little bit of a strain relief going on here. So we want to get the wire in first, and then we're just going to bend these tabs. That's the strain relief. We just got to solder this now, and that concludes the assembly part of the process. Clip off the excess, and that is good to go. That is the assembly complete. That is our complete BDST2 signal tracer ready for action. Now we've got the fun of testing it. Okay, so welcome to another testing lash up. I love a good lash up. Okay, we've got the BDST2 and I've got that currently hooked up to a 9-volt battery. Obviously could rig it to run off an external power supply, but running it off battery is great because you're not going to get any interference. So that's hooked up, ready to go. I've got the probe plugged in here, and I've got the earth of my probe going to a convenient earth from the radio, which in this case is on the power clip, and I'm powering this radio off my bench power supply because I don't have any of those giant batteries you used to get with the big springs on. And it does tell me in here somewhere I can run it off of 4 D-size batteries, which can fit in here, but surprise surprise, I don't have any D-size. I can't remember the last time I used a D-size battery. Anyway, this is a Koyo radio from my collection, which is a very lovely thing, and if you're interested, it is a KTR 1662 BFO, and it's a multi-band radio. It's a very lovely thing. We'll have a look at the front in a minute if you want. Just for testing purposes, this is great because you can get in there nice and easy, and this radio, unlike a lot of the radios in my collection, does work. So what we're going to do is we're going to turn on the radio, turn on the signal tracer. That's on. Should be able to hear that nice and easy. So now this is going to come in very handy when I'm repairing my old radios, because if I need to look for a signal going through, so if I touch this on where there's a signal, so an easy one's going to be the speaker, because there's going to be a signal there because I can hear it coming out the front of the radio. Touch that on there. There you go, can hear that coming out nicely out of the BDST2 there. And you can just probe around. If you're fault finding and there's something that's not working in your radio, we could perhaps find a signal coming out of the tuner if we're lucky. No. There you go. So you can hear that's coming through nice and clear, really loud actually. Other obvious places you can look for a signal would be where the signal's going into the amplifier. There. See, we're good. I should also get something there. There you go. So I won't do too much of that because we don't want to get in trouble with copyright, but you can see how useful this is going to be, where you can trace through. If you haven't got a speaker hooked up to your radio, or it's in bits, or you're part way through repairing it, if you've got a circuit diagram as well, if you can just touch the probe where you know there's going to be an audio signal. So to some extent it could be used in amplifiers as well. I do a lot of amplifiers, but this is going to be really great for working on old radios like this. So got the back on. So this is what we've been using for testing. It's a rather beautiful Koyo radio, multi-band, sounds fantastic, really beautifully made, Japanese made radio this. Perfect for testing our little signal tracer kit then. So another good use case for this is amplifiers. I have here an old ADS PA amplifier. I have a few of these kicking around, so we can use this for testing purposes. So if I just spin this around here, you can see at the back I've got nothing hooked up to any of the outputs at all. All I've got is one input here, which is coming from my little 1Me music source, which is Bluetoothed to my phone. So we've got audio going in, we've got no audio coming out. So if I was testing this amplifier to see where the signal ends, yeah, I could put it on my scope, but how nice is it to have an audible indication that you've got sound coming through. Right, so we've got a bit of crab rave playing on my phone at the moment. So let's turn on the signal tracer, turn on the amplifier. Got a nice little hum. I've got my earth going to the chassis of the amplifier here from the signal tracer probe, which means I can probe. So let's probe on the input to prove there's music going in. Can hear that quite clearly. And let's do the other channel. Yeah, lovely. Okay, so then you can use that to trace the signal through where you know it's going to be. So this is my aux input here, so we know we should have a signal here, which we do. You can see when I change the aux in, so we know we've got sound coming in there. And same again on the volume potentiometer there. That's on the volume one. We should be able to get it on this capacitor here as well. there you go. And we should be able to get it on this capacitor here. Yep, there you go. So you can see how useful this is going to be for repairing amplifiers, repairing old radios. Signal tracer kit, a very useful bit of test gear. So big thanks BD Electronics for sending this over, Bob and Doug. It's going to be really useful. Well, that's what I'd call a successful test. I had great fun building this little kit, and now I've got a really useful bit of test gear. As you've seen, it's really handy for working on old radios and amplifiers. Yes, you could use a scope like this one, but having that audible confirmation that you've got a signal is great. It means you don't have to keep looking up at your scope screen, and to some extent you can also tell if you've got any distortion or a particularly weak signal. So once you know you've got a signal, you can always take a look at it on the scope afterwards for a more detailed analysis of your signal. The germanium diodes in the probe act as a simple demodulator, which can be used to detect the modulated radio frequency signal and convert it into an audio signal that can be heard through the amplified speaker in the base unit. The germanium diode breaks down the high frequency radio signal, or RF, into its audio component, or AF. This is kind of similar to how a crystal radio works, but with amplification. So big thanks to BD Electronics, Bob and Doug, for sending this kit over. I've had great fun building it, and now I'll be able to get to work on some of my old radios. So if you've enjoyed this kit build, I've got some more kits in the pipeline that will be coming up very soon, so keep an eye out on the channel. So I hope you've enjoyed watching today's video, and as always, massive thanks to everyone for watching, sharing and subscribing. If you'd like to go ahead and hit the subscribe button, it's always massively appreciated and helps to support the channel. I'll be back soon with some more tech related videos, but in the meantime, take care and I'll see you on the next one.